Well, looks like we can start. Welcome back, everyone. So we're already halfway through the first week for the course. I hope the rest of your classes are going well, getting started. There was a lot of great questions on getting set up for starting this semester yesterday. And one great question was on the TI-30XS calculator. I took a look into this one, and unfortunately, it's missing several statistical functions to be used well for this class. It has problems where it doesn't have the ability to do normal probability computations or T probability computations, which we'll need for the latter half of the course, unfortunately. Great graphing calculator, great scientific calculator, but just missing those features. We'll be using quite a bit of calculator work once we're getting, say, about midway through chapter 2, a little ways into the chapter 4 starts becoming used a lot more heavily. And like we mentioned before, a highly recommended calculator is this TID4 Plus calculator here, mainly because it's a pretty standard one for statistical classes like this one, and it'll be the one I'm demonstrating in class. So I'll be able to give you the most support on how to do all the functions through that calculator there. Well, that just wanted to get to answering that question as soon as possible. And usually at the start of class, I just pretty much go through the announcements, pause for a moment, and then just turn it over all to you. Any questions that anyone has at the moment? We talked about a lot of stuff last class. Okay, well, if you have just joined this class, I noticed that there's a few additional people who registered as of today. You can see any of the earlier announcements through this link right here. You can see what we did on the very first class on this link here for the recorded lectures. And just about everyone so far has done the major important task of clicking on this Access Pearson link, linking your Canvas course to the MyLab textbook and homework system. So about 70% of the class now has access to the textbook. I mentioned I want to talk a little bit more today about doing the homework in that system. So that's what we're going to do next. Then we'll get started on working our way through chapter 1. So that's our plan for the day. Probably we'll be finishing chapter 1 when we return on Thursday's class based off where we're at, the pacing we're going. And so I moved that due date over. The really keen-eyed among you might have noticed it was September 1st, but I want to have the due dates in this course always be one full week turnaround from whenever we finish that section. I think we'll finish it on Thursday, so we'll be due a week later, September 3rd. Well, unless there's any questions at the moment, don't hesitate to interject with your microphone or chat at any point. We're going to go back to the Access Pearson link and just take a look at how to do the homework. Well, you could click on this link. This is where I would go if you're just going into MyLab to do the reading, opening up the textbook specifically. But if you're already familiar with that, opening up the textbook, and all you want to do is just work on the homework, that's what this is right here. This is a direct link right into the homework at a convenience. So it'll always be right under the section notes that we're working on. So if you click on this, see if it works. It opens up a Pearson link, so just click on this again. I guess it's kind of like using the Access Pearson link. The benefit is if it works, we're going to see pretty soon, it should drop you into the actual homework assignment. And hey, it looks like it worked. This is chapter 1, statistics starts here, the very first homework assignment. I'm not trying to overload us with homework, so I'm going to try to keep these pretty well contained homework sets so that we're not feel like we're doing busy work on a chapter by chapter or section by section basis. These are the homework questions. They'll tell you what points you have on each one of them. And you can just click the start button. You can click on a random question if you like, or wherever you left off on the homework set. I think most people will just click on the start button. Any work you do here saves automatically, so you don't have to print anything out. You don't have to worry about completing the assignment to 100% before you leave your session. If you click on an answer here, check answer, it'll save your work just automatically. And so this is the experience for the homework. A lot of the questions, especially starting out this semester, are going to be multiple choice. So think of this as kind of a skill building section in the homework where you're just trying to get a good idea of what's going on with the vocabulary, the major terms, and these are going to be multiple choice problems. Any questions about the homework at the moment? Okay, well, homework's worth quite a lot in this class, 15% of your total grade. And so one of the things I do with this homework is I don't want you to get overly penalized if you say, maybe clicked on the wrong answer, click check on the wrong answer and you've lost the question. I've given multiple attempts on these problems. In fact, there is actually infinitely many attempts on these because all this is really about is practice, is to help prepare you so that you can do the quizzes and do the exam problems. So, I mean, there's now kind of a right way and a wrong way to do the homework. Sure, you might be able to rip through this by just exhaustively clicking all the options until you get it right because there's multiple attempts that you can make on these. But then you're not really learning anything at all from it. The more you try to really read through the question, think hard about the multiple choice here before you make a selection, the more you're going to really internalize this kind of information. It'll be a lot more meaningful to you. The quiz will make a lot more sense. And when you go to do the exam problems, they'll make a lot more sense too. So try to do these homework problems with a clear conscience of not trying to rip through them, but trying to learn from the problems as much as possible. There's a lot of extra resources in the homework as well. You could click on, if this problem makes just no sense to you, if you feel like you're not sure what they're talking about here when they say sample population, you could click on this link right here, the textbook. And the idea is it should automatically open the textbook into the right chapter and section where this question is related. So that's kind of convenient as well. Let's see if we can get this to work. So I should be able to click open e-textbook or use this upper arrow here that makes the screen a little bit bigger. Either way, it should work, opening up the textbook. Always nervous practicing this on a new computer. And yeah, that did the job. It takes us to the right part of the textbook. You can read through this to get a feel for what the question is about. You're pretty much now just doing the reading at this point. And it's just a convenient way to open to that page of the textbook related to whichever question you're working on. So that's kind of a nice feature. Tech help is if something goes wrong. So my hope of hopes is you never have to use that button. But if anything is going on, don't hesitate to ask me about it. I'll try to work with any technical issues to the best of my ability with you. And if there's just something I can't figure out either, I'll work with contacting technical support on your behalf. There's also another curious button, Ask My Instructor. Everyone in class is welcome to use this button as much as you would like. If you click on this button, you can send me a message, and it can be any message, maybe even just, I don't get it, anything along those lines. It'll tell me what section, what question, and it's not the best system because what this really does is it sends a direct email. And when I see that email, I can't actually respond to it. And you see a reply here in the system. What I would have to do is I need to email you then directly, your ISU email address, to give you my response. So the Ask My Instructor button is really just a shortcut to emailing me about the question, and then I email you back. So that's pretty much the tour of the homework section. I think a couple folks have already tried giving some of these problems a go to see how this works. Any questions or comments or concerns whatsoever with working the homework? Okay, well, I do have more things I want to talk about in the homework, but I want to give everyone a chance to work on these, give them a try, let me know if any issues come up. And we'll talk a little bit more about due dates, accessing late homework and that kind of stuff after the first due date passes. So we will return to these things and discuss them later on in the course. I feel like talking about every single aspect of my lab and the homework system all at once on the first or second day is just sort of overwhelming. So give the homework a try. Let me know if any issues come up and we'll go from there. And by the way, there's really a couple kind of schools of thought of how you might want to start this homework. Some people want to just click in there, get it done as soon as possible. But there's a kind of a small conflict where we're still working chapter one. We're probably not going to finish chapter one until sometime on Thursday's class. So if you begin the homework, you will inevitably run into problems that we just haven't covered yet. If that feels uncomfortable to you, no big deal. You can start chapter one the moment we finish chapter one. If running into problems we haven't done yet in class is no big deal to you, then you can move forward in the homework. You can work a little bit ahead. I have up to chapter one and section 2.1 posted. I don't have anything beyond that because I'm putting this together section by section, just to make sure the questions that I assign are similar to the problems that we actually did in class. So I think that's my whole spiel for the announcements on getting started with the homework. If you want to give an early start, you can work one or two problems. Once we have chapter one 100% completed, that due date's official, and that means all the problems that are inside here, you should be able to do and be familiar with. And by the way, if questions come up, everyone is always at any point welcome to ask questions, whether it's in office hours, a direct email to me, or questions at the start of class, questions towards the end of class. They can be anything whatsoever, over quizzes, homework problems, etc. So I guess that's my whole spiel to start us out. We're going to go to example 2. But any last thoughts or comments before we get started with today's work? Okay, well, let's get started. We only took 12 minutes this time, a lot less than last class getting started. Usually we'll only spend a few minutes on announcements unless there's a question that comes from the class before we jump into the material from last time. If you click on these notes right here, it contains the solutions that we did before ending class on Monday. So if you want this file as a blank file, go to this folder like we mentioned before. So here's where we left off. It's a tough problem because we had to analyze the context about ceramic hip replacements for all people that had a ceramic hip replacement between 2003, 2005. We called that the population. It's the collection of all individuals we are trying to learn about in this particular context for this study. So the population is everybody that had a ceramic hip replacement between those targeted years, 2003, 2005. The sample is just part of the population, hopefully selected in a way that makes it representative. Maybe it's a random sample. And this particular study that came from the May 2008 issue of New York Times selected 143 individuals with ceramic hips between those 2 years. So that's what gave us the sample in this study. So we mentioned this is a big part of statistics, analyzing the population versus the sample. And there's quite a bit more going on with statistics. It's a hard subject to really introduce and say exactly what it's all about on the first day. It takes a long time to do, takes a lot of time to do so, but it's, in my opinion, well worth taking that time to say exactly what we're doing in statistics. So we're going to go further on this problem. I put a little border here to say the problem is done, and these are additional remarks down below. This is our attempt to introduce what statistics is really all about, what we will be doing in this course before it's over. Any questions first about either parts A or part B? Okay, so let's go a little bit further with this problem. You notice that there's some data here that we really didn't say much about when we were describing the population or the sample. We did mention 143 individuals in the sample, but the study is all about ceramic hips that begin to squeak after they've been installed. I don't know if installed is a very sensitive way to say that. After the procedure, there was 10 in the sample that developed squeaking. So you might already be thinking about some computations you might want to do there. So here's the big idea, which is going to introduce let's call this Introduction to Inferential Statistics. So this is the major idea that this course is really all about, inferential statistics. Inferential is coming from the word of making an inference, making some kind of conclusion from our sample data. So to visualize this, let's begin with a population. I want to visualize it as just a big circle here. So everyone in this big circle, kind of like a Venn diagram, belongs to this population. Everyone in here had a ceramic hip replacement between 2003, 2005. So we know what that population is by part A. I'll just call it population. We can't study that entire population necessarily because there's potentially hundreds of thousands of people who had those hip replacements. So we do the big idea in statistics and just study a representative sample. So let's say here, take a representative sample. We'll talk more along the course, what we mean by representative sample, how to get one. But the idea is our representative sample of 143 individuals should have no big biases. It should well represent everyone in the population. There should be multiple age ranges, multiple different kinds of people that are inside here, and so on. So here we're studying next the sample. And there's two kind of quantities that we want to really study. Over on the left, we have something called a parameter. The symbol we'll use for that parameter will be a lowercase p. P will be population proportion of hips that squeak, referring to, once again, this population, all individuals with a ceramic hip replacement, and those hips are the ones that squeak. So we have a population, and P is their true proportion. Instead of proportion, you can say percentage, and that's a fine way to think about that quantity as well, of everyone with a ceramic hip that squeaks. So trouble here is P is unknown. The only way to calculate P, the massively important object right here, which we call parameter, is you have to study every single person in that population. Once again, that study is probably too costly. It can't really be done. So we're studying a sample instead. New York Times, instead of contacting hundreds of thousands of people, they contacted 143 individuals instead. So what we often write down is N equals a sample size, the size of the sample of individuals we're studying, and in this problem, N is 143. When we describe the sample using the context, the sample is not just the number 143, it's the 143 individuals with a ceramic hip replacement that the New York Times actually contacted. So this N just says how big the sample is. And within this sample, we go from the word parameter to the word statistic. The statistic has its own special symbol. We go from the symbol P. That's the thing everybody wants to know about, that they're trying to study, trying to estimate in some way, but it's a true unknown. We estimate it with P hat. So P with kind of a little up arrow symbol above it, we just read that as P hat. That's not a bad note to just make here on the margin. We'll come back to that symbol. That is read as P hat. So I guess that's the hat right up there. So P hat, this is going to be equal to the sample. Let's make that possessive. The sample's proportion of hips that squeak. So that's our major dichotomy in statistics. The population is everybody. The parameter describes the entire population. Sadly, in statistics, it's often unknown when populations are very large, like in this case. So the other side of the problem is we're going to study the sample instead. We're going to make an estimate. Make an estimate means we're going to calculate a statistic, and that's the P hat here, the sample's proportion of hips that squeak. Let's say down below, P hat can be computed. In fact, let's compute it right here. P hat, it's a proportion. We can convert that into percent if we prefer, but let's leave it as a proportion. Just means it's a fraction. We take the number of squeaking hips. There were 10 of them, they told us, in that sample of 143. We divide by the sample size, 143 individuals altogether. Some people were doing this kind of computation in their calculator on the first day as well, either 10 over 143 or 143 over 10. So this is the sample proportion of squeaking hips. As a number, let's throw this into the calculator. This is 10 divided by 143. So as a proportion, we might call it 0.0699. If we want to make a unit change, we can multiply that by 100. Now it's as a percentage, 0.699%, or excuse me, 6.99%. So P hat has been computed. We still haven't said exactly what inferential statistics means, but here is now the really, really big idea in statistics. The unknown, the thing that we really care about, P is approximately equal to P hat, the value of the statistic from the sample, which was, I'll use the percentage, 6.99%. So when this study is conducted from New York Times above, they can make a conclusion that approximately 6.99% of the population, we're talking about P, for all individuals who had the ceramic hip replacements between years 2003, 2005, just reading out part A, is about 6.99%. So even though it's unknown, we can still estimate it, and we do that using the sample itself. So that's our all-around big introduction to statistics. It's telling us not the complete story just yet, but tells us what we're trying to achieve. We're taking humongous, unwieldy populations and try to give as best estimates as we can. Well, again, this is an introductory problem. The homework really ends right at the border down below, but I think it pays to think about this problem right away on the first week of class, because these are some of the big ideas that we'll be coming back to over and over again throughout the semester. Any last thoughts or comments so far with this introduction?
I have a question about the P. Does that stand for the population or the parameter?
It stands for the parameter itself, which describes the population. But yeah, when we say parameter, we mean that P right there specifically. And likewise, when we say statistic, we mean the P hat specifically is the statistic.
Yeah. Okay. Thank you.
You bet. Thanks for asking about that. That's one of the things that's kind of tough about starting out with statistics is there's a lot of vocabulary. And it's more technical than it looks, right? The definition here is short, but now we have new definitions, parameter versus statistic, and it just keeps on piling on. So we take a lot of time learning this vocabulary so that things start to click together a little bit better as we go along. Other questions at the moment? Okay, there's still one more piece that we need to add here. And again, we're going to come back to this problem when we're able to analyze these data in full. This will be sometime after midterms. When we made that approximation right there, let's emphasize what we did. Approximate, approximately equal to, we said the parameter P is approximately equal to the statistic, but there's a big problem right there. So here is our major, let's call it problem. We're going to fix this, but for the moment, we should say why this is not an 8-week course. This is a full-on 16-week course because of that major problem right there. You can't just give an estimate unless you tell people how reliable your estimate actually is. Let's put this in words. This estimate is useless. That's kind of a mean word, but it's accurate. Is useless until we can describe how accurate it is. Just kind of hoping I had a little bit more space here. Let me see if I can manufacture some more white space. Yeah, just a touch. It's useless until we can describe how accurate that approximation is right here. The margin of error must be computed. So we can't say that P is approximately equal to 6.99% unless we say how reliable that error is, give a margin of error. Maybe it's off by 3%. Add 3% to that, subtract 3% to that. It's a pretty wide margin of error. But that also gets involved with probability when we try to describe margins of errors as well. So that's why we need the normal distribution, fancy calculators like these, so we can start working with probabilities when we go to describe how accurate that estimate really is. So out of nowhere, it becomes what would have been maybe an 8 or 10-week course. But to make that estimate more descriptive and how much confidence we really have in it, it becomes a 16-week course altogether. So this is the major ideas that we're going to be working through in statistics. There are other ancillary topics, but this is the big one that we'll come back to here and there throughout the course as we get further and further along, and we will finally solve this problem and many others like it. But that's our introduction to statistics. Again, it takes a long time to really introduce what statistics is all about, but it's well worth that effort. If everything seems kind of vague and confusing so far, again, we're going to come back to these ideas throughout the semester. The major takeaway from example 1 is part A, part B, and we're going to practice it again in the next example. But any last questions or comments with where we're going, what the major issues are so far? Okay, well, let's move forward then. So far, the big ideas are population versus sample, but we can expand on that a little bit more and talk now about data in general, along with the 5 W's and how. So here's our next section of definitions. This is not the easiest word to define, but I think our author did a good job. We think of data as any collection of numbers, characters, images, or any kind of identifying information that provide information about something. Maybe they're people, For example, people with ceramic hips, maybe they're objects, for example, cars on a freeway and so on. But that's what we mean by data. Any kind of collection that describes essentially a population or a sample. So data itself doesn't have any meaning whatsoever unless you have the context. And that's the major struggle really on example one. Example one isn't about the number 143 or the number 10. It's about all of this context that we had to write down in words about people with ceramic hip replacements. The fact that some of them began squeaking gave us the statistic as well of about 7%. So the context is the next major challenge in statistics. We take a lot of time in this class taking problems like these and the one example one to break down the context with the major idea of try to get population and sample. But we can break it down further into the 5 so-called W's and how. The context of the data should tell us, ideally, let's come back to that word in a moment, who was measured, what was measured. Here's the how the data was measured, where it was collected, when it was collected, and why it was collected or why the study was performed in the very first place. So if we can answer all of this right here, then you've got an amazing context behind what's going on. And now the data really comes alive. It now has meaning. We can analyze these numbers, give strong conclusions, tell people what our conclusions really mean. So that's our first set of definitions. And there's a bit of a carryover. Let me make sure my color coding's the same. This kind of expands on what we were doing just in the last problem. When we say who was measured, that's just the sample. When it says what was measured, this is going to be in the next set of definitions. We're going to call those the variables. And the next part, why the study was performed. This is also an important thing to think about. Usually when you're looking at a big study, there's some kind of research question in the background. On example one, the question in the background is, how many people with those ceramic hips, what is the proportion of them that have squeaking hips? So why the study was performed? This is essentially the question. The researcher is trying to answer using a representative sample, using data. So this is the 5 W's and how. I hate it's referred to the 5 W's. It includes really 6 things altogether. We won't do this kind of problem very often. It's more for us just an exercise of breaking down the context as finely as we can. The major things that we really will study quite a bit more are, like before, sample and population. So here we're just going a little bit further. So first thing we've got to do is carefully read the context. And again, it's not a bad idea to read it several times, especially if the problem is slightly higher stakes, maybe a quiz problem, potentially an exam problem. So let's see what's going on here, carefully reading through this. It says to start, people who get lost in the desert, mountains, or woods often seem to wander in circles rather than walk in straight lines. And I probably kind of knew that from popular culture, different kind of movies. It's a sad fact because this is counter to your survival if you're walking in circles and you're lost somewhere. To see whether people naturally walk in circles, they're not just scared, in other words, not just in a survival situation. Maybe this is just a feature of how humans walk. To see whether people naturally walk in circles in the absence of visual clues, researcher Andrea Axtell tested 32 people on a football field. Okay, so that kind of builds an image in our mind. We have 32 people. We're going to see if they walk in straight lines naturally or in circles naturally at an absence of visual cues. So to bring this to life as much as possible, researcher Andrea has to work kind of hard on this. And this is what she did. One at a time. So they're talking about the 32 people on the field. They stood at the center of one goal line. I don't know if they were in the front or the back of that. There's minimal information here, but they're on the center of a goal line. They were then blindfolded, so we have lost visual cues, hopefully, and then tried to walk to the other goal line. Imagine you doing it yourself. First time I read this problem, I thought, this doesn't seem like too big of a deal. So what she did was she recorded each individual's sex, height, handedness, the number of yards each was able to walk before going out of bounds, and whether each wandered off course to the left or to the right. It then says no one made it all the way to the far end of the field before crossing one of the sidelines. That's kind of concerning in a way. And I did some research here. A football field is 120 yards, which is 360 feet. It's not a short distance, but I think a lot of people, me included, imagine that they could have walked to the other end, starting in the center, even blindfolded, but out of 32 tries, nobody made it. So it's kind of interesting data. It's fun data because it's relatable, maybe more relatable than imagining a total hip replacement, for example. Any questions or comments whatsoever with the context of this study? Okay, well, let's start breaking this down further. The 5Ws and how is now like a scalpel where we're trying to find all of the moving parts inside this context. A context ideally can get us the 5Ws and how, but sometimes there is missing information. So if there's something that we can't answer fully, we'll just say unknown. That's sometimes the case with these kind of problems that we do in class. Just so they don't become a page long in context, they're short and sweet, kind of like the abstract to a study almost, or even shorter. So we just do the best we can with the context that we were given. So let's go just down the line. Who was measured? This will be referring to really the sample of the study. If we read through this, it says, well, Andrea tested 32 people, so that should be the who of the study. Yeah, absolutely, Kaylee, it would be those 32 people. Now, let's say 32 people. Let's imagine that this was, say, a quiz problem or maybe an exam one question. I would give full credit to that. You really got to the heart of who the study is about. But let's be nitpicky on this one because this exercise example 2 is all about thinking of the context. If you had to say a little bit more, what else would you say? It's 32 people, but we could be more descriptive. Any volunteers for adding more detail? Yeah, they are absolutely, we're blindfolded. Let's add that here. 32 people blindfolded. I think the blindfolded might be part of the how, but I wouldn't say it's not too much harm adding it here either on the who. We could call them participants as well, but that's kind of the same thing as calling them people. True, they did have different sexes. We had males, we had females. But there's one other thing that's probably really important here about the 32 people. Well, the who wouldn't be less about the researcher, more about the actual participants of the study. But imagine again, we're taking people, we're blindfolding them, we're having them go on one end of the football field to the other end of the football field. And so when we're thinking about this kind of study, automatically certain people really are excluded, right? When we go to say 32 people, let's keep the blindfolded maybe for the how part. If you put it here, I wouldn't dock you credit. But we should say 32 people that are They're probably adults, at least teenagers, right? There's probably no 5-year-old in the study, in other words. There's probably no 1-year-old whatsoever. So if we were being really specific here, we would go beyond 32 people and say that are adults, not just any adult. It's implied that they're walking, right? So someone in a wheelchair, that might still be interesting. If you could, in a wheelchair, go in a straight line, that's interesting on its own right, but doesn't sound like that's what the study was all about because they all had to walk. So we might say 32 people that are adults and can walk normally. So that's probably exactly who was in the sample. This is important because it informs us of what the population is. It's going to exclude very young people. It's going to exclude anyone that has a physical disability that can impede normal walking. And so thinking about these extra details right here, even though I would give you full credit at just the 32 people, this is helping us quite a lot on fully saying what is the population really? Not just anybody. They have to be people who would be walking normally. I think that's about all I would add. Any questions or additional things you would add on to this one? Okay, thanks for the brainstorming on this one with me. Again, there's a lot to think about when it comes to these kind of breaking down problems in their contexts. This is only our second one this semester, so we'll be practicing this quite a lot. By the end of the entire course, you'll be an expert at just looking at these kind of problems and really seeing it from a different side. And sometimes a great strategy here is try to visualize the problem in your mind. Pretend you are Andrea. Pretend you're watching as this study goes, try to play out a movie in your mind of what's really happening. The more you can try to visualize this, the more you can try to see what makes sense as you go to through the context on the who, what, how, and so on. But let's go on to the next part. What was measured? So,
The
in,
distance traveled without crossing lines in the
yeah,
field.
absolutely. Kaylee also says ability to walk in a straight line while blindfolded. So they measured that by, as you said, looking into the distance they went. That's the number of yards. But they also looked at whether they wandered off course to the left or the right. That might be interesting. They looked into whether the participant was left-handed or right-handed. Maybe that has something to do with it. Maybe right-handed people wandered off to the right side more often or the left side more often. Who knows? It's probably interesting to actually look into these data to see what's going on. Maybe height is influence. Who knows why that might be the case? Maybe sex is influence. Again, who knows if that really influences whether you went off left or right or how far you went. But in case any of these different variables made a difference, Andrea is not just measuring how far they went, whether they went out of bounds, left or right. Andrea measured all of this stuff. Let's highlight that there. That's essentially the what of the problem, all of that. And again, I'm not going to be hypercritical if you were doing this as, say, a quiz problem. You just told me how far they went before they walked out of line, out of bounds. There's more to it, but you kind of got to the heart of the study, what was measured. Let's put down everything that was measured. Andrea measured sex, height, handedness, number of yards each was able to walk before going out of bounds. That's kind of irritating to write that down. And one thing I want to mention as just advice, especially in an exam setting, if you're taking an exam, they're timed 75 minutes, and it feels like you're writing down a lot of stuff, you could paraphrase things down just a little bit. You could take this and just say briefly, number of yards. You might say before out of bounds, but if you just capped it off at number of yards, The context above already applies number of yards each was able to walk before going out of bounds, and that would be a fine response. So if it feels like you're writing down the whole problem all over again, just know that you can sometimes shorten things down so it doesn't feel like you're just writing down a whole bunch, cramming it in. That can save some time in an exam setting, and it's useful for quizzes as well. So here's the last one. Whether they're off course to the left or the right, and we can again paraphrase that down to off course, left/right. You can phrase these differently. You might say left off course, right off course as the next part of the what, which is essentially, again, the variables. And as long as you're on target, you get the main idea down. If you missed one or a couple of these, I'm not going to be hyper picky when I go to grade a problem like this one. Well, that's the what of the study. Any last questions or comments with the what portion? Okay, and again, we're now getting through 6 portions. We're halfway there. How about the how? What would you all say for how the data was collected?
Um, on the football field, controlled setting.
Yeah, absolutely. So essentially, it's this information right here. Let me capture what you said on the football field. They're in a controlled setting. So this is some nice research they're doing. By controlled setting, what they did was they were blindfolded. Let's put that there as in a parenthetical. If this is your full response, even before the parenthetical, I would say that does the job. It kind of visualizes how the study was being carried out. They were put on a football field. The controlled setting really paraphrases the fact that they were blindfolded and then tried to walk to the other goal line. And again, paraphrasing here is okay. If you're just directly copying down the whole problem, that's not always necessary. And so if you mentioned it just like this, I think that'd be a completely fine response. Some people might add and ask to walk from one end to the other. That would be just fine as well. Let's leave it off a little bit shorter on this one, just to emphasize it's okay to paraphrase here. We don't have to recopy the entire context down. So that's the how. It tells us how the study was really conducted, what was really going on with it. Let me see if I can scroll down just a touch here. And we're moving on to the next W, where the data was collected. That one's a little bit tough. I mean, we know it's on a football field, right? But I don't know if this is, say, a ISU's football field, or if this was a professional football field, a high school football field. We're not even sure if this was a regulation length football field. It just said when at a time they stood at the center of a goal line, were blindfolded, then tried to walk to the other goal line. Let's see, nobody made it to the far end of the field. I'm pretty sure we're talking about football fields. Oh, it says it right here on the who. But we have no idea beyond that where this was really done. We don't even know if it was done in the USA or in a different country whatsoever. So that's where the ideally comes into play. Sometimes we can't answer all of the 5 W's and the how. And if that occurs, we can just say for the where, an unknown is a completely fine answer. If you say football field, well, that's really just the best we can do with this one. Let's say on some football field, and I want to add here, just in the parentheses, or unknown, it would be a completely acceptable answer to this one. We really can't say too much of where it was conducted. And maybe that's important. Maybe altitude is a factor here. And if they tested this at a high altitude, 6,000 feet, some people might wonder what would happen below sea level or at sea level. Maybe it's the same outcome, but you never know what factors could influence a study like this. So the where is an unknown. Let's think about the when. Anyone see any information about when this was done?
In the daytime.
Probably in the daytime for sure. So let's say during the day. I think it's implied. I don't know if they said it directly anywhere, but it feels implied, right? It'd be weird to imagine this was done at 3 a.m. It would be going beyond their ability to walk in straight lines and the lack of visual cues. Now you've got like insomnia factors added into the study, which seems to be going beyond the spirit of the study. But we can answer even more about the when, potentially. We'd want to, for example, try to narrow down what year, what month, what day of the month, even. Those factors might be important. Maybe if it was done in the summer, the sweltering heat versus the winter where people are shivering, maybe that's a factor. Like, probably not, but it's informative to us to try to nail down the when as best as possible. Anyone see any information that can nail this down just a little bit more? Yeah, I think that's a good eye right there. The one hint is there's a source, Stats Journal, issue 39, winter 2004. It doesn't say it happened in winter 2004. What it means is Andrea's study was published in winter 2004. But at least it gives us the best information possible of when, in terms of years, this was done. So let's put here, good eye on spotting that date, that year, on or before winter 2004. So this is pretty old data, possibly 22-year-old data, depending on when the study was really conducted. Maybe that's a factor. It hasn't been replicated in a very long time. It's 2026 now. But in some problems, especially medical problems, the year when this was done, at least having that information is vital. Medical technology, like say installing ceramic hips, changes very, very rapidly. And so sometimes the when is critical. Your study might be useless if the data is too old, in other words. So that gets us through the when. Again, good eye. It's just kind of hidden there. It doesn't say specifically it happened in winter, but that's when it was published. So we say on or before that date there. And honestly, for the when, if you called that one just unknown as a response, I think that's pretty appropriate too, because we don't have perfect information on the when either. Finally, the last thing is the why. Here's the last W of the so-called 5 Ws and how. The why is essentially asking ourselves, when you read through this problem, why did we do this? Why did we subject 32 people to humiliation of going out of bounds when they thought they could possibly make it to the other goal line? Here, this is really about what is Andrea, or imagine you yourself are the researcher behind the study. What question are they trying to answer? We can go back to the start of the context, and this gives us another hint. Kaylee says, to see people naturally walk in circles in absence of visual cues. And Sierra also is mentioning absence of visual cues. Absolutely, that's what this problem is all about. And notice as you get all the way down to the why, you might have forgot about some of this information right here at the top. That's why, annoyingly, sometimes it's a good idea to read through the context multiple times through the course of solving this kind of problem. I want to write it down in more similar way that Kaylee wrote it down. Pretty much just writing this down because I want to emphasize If you did cite a portion of the problem directly and just quote it down below, that's appropriate as well. You don't always have to do that. Sometimes paraphrasing is a good idea, but this time let's just directly quote that sentence by the red dot. The why is to test whether people naturally walk in circles in the absence of visual cues. So that's the full rundown of the context. Again, this is like taking a scalpel to our study right here and trying to identify as much as we can of all the moving parts that makes up the context. We can do that. Whatever information Andrea provides on these 32 people, that data is now well identified. It has context. It now has meaning altogether. And if you go through this problem, you're curious about the data, some of our problems will have direct sources like these. If it doesn't and you're curious, don't hesitate to send me an email. I should be able to find a direct source for you most of the time. Occasionally, some of the problems are just made up data, but those are not always my favorite kind of problems. Well, we did it, folks. That's the 5 W's. Going through that, we can now also address what is the sample and what is the population. Let me do just a quick scroll here, just for the sake of quick reference. Now, we kind of already mentioned the who is telling us what the sample is. So let's just copy that in. The sample. I'm going to write this one in really briefly. I'll just say the 32 people tested, blindfolded, told to walk from one end to the other of the football field. Now, the sample is the part of the population that was selected for study. And if we're really kind of brief here, just say 32 participants or just 32 people, if that's all you said, that could qualify for the sample because we get the full picture when we say what the population is. It's the collection of all individuals or objects that you want to learn about. And one word I forgot to put here in the notes is usually as when we do this kind of problem, like on example 1, it'll say on a quiz setting or an exam setting, using the context of the study. Since I wrote that in, let me put that in red so you can see where the edit was. I think that's a good edit because that's how usually the problem would be asked as a quiz or an exam problem. Now, when we go to say population, first thing I want to say is this is about people. So we want to say all people, but not necessarily all people, right? Because that might include the geriatric population, people who are very old, possibly in walkers, or they cannot walk at all, people very young, so we don't want them either. We don't want toddlers who are crawling, for example. That's not in the spirit of the study. And we even want to go beyond people who get lost in the desert, mountain, or woods. We're really wondering about people, all people, whether they got lost or not. So whether you ever are lost in the Sahara Desert, before that even happens to you, hopefully it never happens, we're still curious about whether you walk in a straight line or not. So it really is all people, not just those that are, say, getting lost, for example. The population is pretty wide on this one, but they have to be able to walk normally. So we should probably say all people, maybe use the word adults if you like. If we lost that word, we can still just say this portion, all people that are able to walk normally. Whether or not they get lost or not, we're still curious on the why to determine whether all people who can walk normally, we didn't say that here, but we really want to know whether or not people are going to walk in circles in the absence of visual cues, whether or not they're lost on a deserted island, for example. So the population is really everybody, like we emphasized here on the all. The sample was just the 32 people Andrea has access to. Andrea cannot ask billions of people to walk from one goalpost to the other. Instead, she selects a sample, hope it's well representative, both sexes, a good proportion of people might be left-handed, representative of the global population, various heights, and so on. And she just tested those 32 in the hopes of better understanding everybody that can walk normally. So that's our sample versus population on our second example. Any questions or comments at all? Anything that you'd want to include or exclude? Okay, thanks for your brainstorming and your contributions on this one in the chat and over voice. The more you're kind of involved thinking about the problem along with the class, the easier these things are able to put together. When you go to do the homework is same kind of ideas, identifying population versus sample for the first several questions. You have still a ways to go in these notes, so we haven't covered everything yet in the homework. And it looks like we have about 8 minutes and some change. So let's take a little bit of a look into the next portion. But I'll try to always end right around 7:10. I'm never going to try to go beyond our ending time. We're all busy people. You have other things to do, other classes. So I'll try to end at 7:10 as sharp as possible. So we got through saying what data is by using the context. We mentioned the who was the sample of this, but the what is the variables. So we have a little bit more we want to talk about when we just say variables, and that's what the next portion of the notes are altogether. A variable is any characteristic whose value may change from one individual, we're talking about people in the sample, to another. So in this problem, the what was the variable itself. Let me put here just a quick note as a reminder. This is the variable, the variables of the study. We say next, data results from making observations either on just one variable. Maybe all Andrea tested was, let me bring that up a little bit higher. If there was one variable, maybe it might have been the number of yards, or maybe whether they went off course left or right. But oftentimes study like these is simultaneously made on 2 or more variables. Andrea had altogether 1, 2, 3, 4, 5 different variables that were measured. These quantities changed from person to person. Some people had the same values, maybe for the first variable, for example. Maybe just by luck, some people might have had the same height. But in general, across the 32 people, we expect these 5 different values to change from person to person. So we call it a variable altogether. It varies from person to person. And data is just the result of collecting all of those observations. So that's our next level in dissecting a study. And our next context is really very, very short and sweet. That's kind of nice in a certain sense. We're going to be analyzing the variables on this one, the population versus the sample as well. Oh, I think I missed a chat. Kaylee says, I think you went over it yesterday, but do you post these notes with all the edit solutions we have made in class? Yeah, absolutely. Thanks for asking about that, Kaylee. The last thing I do is when class is over, I take in all questions. I go here and I just delete this file. I re-upload it with everything that we've done so far. So if you were to open up this one just right now, you'll see that it's no longer blank. It's got the thing that we did on the very first day written in. Other questions at the moment? Okay, well, here's our next problem we're going to analyze. Again, the context here is kind of short and sweet. We're going to keep on working through those tough definitions of population versus sample. Again, I probably should have done a better job with writing out these notes. I'm trying to write out my notes in a way so that they're similar to the way I'd actually ask a question on a quiz setting or exam setting. So let me add here, describe the population of interest using the context. And same statement here. So we're going to delve into population sample really carefully before we get into the variables. But any volunteers for a quick answer on what you might say either one of these are? Let me keep my color coding the same. We're doing green for sample, blue for population. I don't want to change that suddenly. Sorry for the switch on that one. So one hint on this problem, and again, we're going to solve this one completely and fully when we come back fresh on Thursday's class. But one hint is when it says 53 representative lakes, that's pointing us towards the sample. So like Nakizaka said, lakes in Florida, if we say lakes in Florida, we're now thinking about the population. We're interested in all lakes in Florida. So if that's your response, put that one under population. If you say 53 lakes in Florida or 53 representative lakes in Florida, now you're talking about the sample, what they actually studied. There are a lot of lakes in Florida. I haven't researched this to know the exact number. That's probably a hard number to even get exactly. It's probably an estimate. So they're going to just study the 53 for the sample. And when you say lakes in Florida, you're now talking about all of them, it's implied, for the population. But again, we're going to start with this one fresh and delve through it, take a look into variables. We'll next look at different kinds of variables, categorical versus quantitative, look at a slightly bigger study, and end with just a fast one, classifying different variables as categorical or quantitative. So it looks like we have a good amount of work to do. Took us a little bit of time to talk about the introductory problem under example one. But again, I think that's well worth our effort since those are the big ideas we'll keep on coming back to. So this is where we're going to start when we come back on Thursday's class on example 3. But any last questions or comments at all, folks, before we call it a day? Okay. Well, these problems are sometimes kind of long in statistics, and what I'm going to try to avoid to the best of my ability is not start a problem that we have to finish the next class meeting. Sometimes that will happen, but I'm going to try to avoid it. So today we're going to end just a couple minutes early, just because I don't want to run over class time as well. So if you have any questions or comments, I'll be happy to help you out. But otherwise, have a great rest of your afternoon, folks. We'll be back to this on Thursday. Thanks. Have a good one.